Good day, students. Welcome to mathgotserved.com. And this clip we're going to be going over how to graph absolute value equations. This is under the linear equations section of our virtual algebra text. Now there are two ways that we can graph absolute value functions. We can use piecewise defined approach, or we can use the transformation formulas. Our focus in this presentation will be the method of transformation of the parent absolute value function. Okay, so to get started, we're going to take a look at the transformation formulas. So the transformation formulas are as follows. Transformation formulas. Alright, so the function under consideration is the absolute value function when you see f of x. Now if you have f of x minus h, okay, in this particular form, the transformation is going to be a shift h units to the right, okay, because it's minus h. Now if you have the function composed with x plus h, basically the number grouped with x is positive, that's going to be a shift in the opposite direction. It's going to be a shift h units to the left. Now the next transformations involves a constant that's been added to the function. So if you have a function plus a constant, let's say k, in this case you're going to have a shift k units up. Okay, and then if you have the function minus k, you're going to have a shift k units down. So the difference between the h and the k is that the h number that's grouped with the x, the movement is normally opposite of what the signs indicate. Alright, so you know your x-axis goes left and right. If you have minus a number with the x, you're going to go to the right, which is counterintuitive. And if you have x plus h, you go to the left. But on the flip side, the number that you're adding to the function as a whole, the shift, the sign is in harmony with what you would expect. Okay, so let me give you a visual. So if you have f of x minus h, if you had an original function like this, an absolute value function, if you have h units to the right, you're just going to shift it to the right h units, and then you're going to have your new function. Okay, and if you have f of x minus h, originally you have an absolute value function, and then you're going to shift it to the left to get your transformed function. Okay, so these are just movements in the direction of the x-axis. Now in this case right here, x minus h, you're going to have a function at the bottom, at the origin, and then you're going to shift it up h units like that to get the final one. And then for this one right here, if you have a function and you shift it k units down, you just shift the entire function straight down. Alright, so this is what we're going to be doing. We're going to be shifting left or right depending on these two, and then up or down depending on the last two that we have here. Alright, let's take a look at an example. So we are to graph the given function, graph the given absolute value function by transformation. Remember, you can also do this using a piecewise defined approach where you break up the function into different pieces and you graph them one at a time in their respective regions. So let's say we have y equals the absolute value of x plus 3 plus 1. Okay? Alright, so there goes the absolute value function that we are going to graph. So we have y, which is the same thing as f of x, equals the absolute value of x plus 3 plus 1. Alright, so let's write it in function format. So you have f of x is going to be, now you notice that the 3 is grouped with the x, right? So you have x plus 3, like that. So you can put the absolute value bar there. So let me change that. So we have x minus h for absolute value. So absolute value of x minus h plus k. All right. So let's go ahead and talk the transformations. We're going to deal with the shifts first. All right. So we have the function is composed with x plus 3. All right. You have x plus 3 grouped with each other. So what kind of shift is that? Remember, you have x minus h for the general formula. Whenever you have minus, that means the opposite, okay? So instead of thinking, oh, you know what, the x-axis goes left and right, since I have plus 3, I'm going to go to the right. That's wrong. It's the opposite. You're going to shift 3 units to the left. Why? Because positive 3 was grouped inside of the absolute value function with x. So whatever is grouped with the x inside, you do the opposite in the direction of the x-axis. And then we have the function plus 1. You have this plus 1 out there. This again. The function plus 1. So 1 is being added to the absolute value function. Okay? But since it's plus k, that means that the move will be in the direction you expect. So plus k affects the y. So this would be a shift 1 unit up. All right? So these two shifts will take us to a new vertex. And our new vertex is just a combination of h and k. And it's going to be, now if you start from 0 and you go 3 units to the left in the x direction, that will take you to negative 3. And then if you start from 0 and you go up 1 unit in the y direction, that will take you to positive 1. Alright, so shifting 3 units to the left and 1 unit up will take you to negative 3, 1. Okay, so let's go ahead and sketch the graph of our absolute value function. All right, we're going to draw the original function first, and then we will apply our transformations on that function in order to see exactly what it looks like. All right, so the original function coming up, let's make that in red. All right, so this is what our original function is going to look like. Let me make it broken. This is the original absolute value function. You rise 1, you run 1, rise 1, run 1, because the slope is just 1, to the left, and then the same procedure to the right. Okay, if you want to know where the points are, let me put them in for you. For the original absolute value function, you start from 0, 0, position this properly, and then you rise 1 and run 1. So rise 1, run 1, right there. Rise 1, run 1, and then the same on the left side. It's just a V, okay? Rise 1, go back 1, rise 1, go to left 1. All right, so this is the original absolute value function, which is y equals absolute value of x with no change applied whatsoever. Now we're going to carry out a transformation on this function right here. Let me show you what it is going to look like. So what we're going to do is we're going to shift this function 3 units to the left, and then we're going to shift it 1 unit up. Okay, so it's going to look like this. So go do that again. Let's take it out. So you go 3 units to the left, 1 unit to the left, 2, 3, and then you're going to go up 1. Bam. That's where the final function is going to be. Okay? So you shift the original function 3 units to the left, and then you go 1 unit upwards. Alright, so I'm going to go ahead and graph it for you so you can see how it looks like. Let's make it blue. So our vertex is negative 3, 1. So we're going to go 1, 2, 3 to the left and 1 unit up. Alright, so we're going to graph our v function here. So you just rise 1, run 1, rise 1, run 1, rise 1, run 1 to the left. That's for the v. Rise 1, go back to the left 1, up 1 to the left 1. Alright, so these are the points that define our new function. So this one, since it's the final answer, we're going to graph it using a solid line. Okay, so start from your vertex and you go up. That's the right half of the function. And then you start from the function and then you go up. That's the left half of the function. Okay? Alright, so what did we just graph? Let's write down the name of the function that we just graphed. The name of the function that we just graphed is actually the original, which is the given, not the original, the given, which is y equals the absolute value of x plus 3. So this x plus 3 caused the graph to shift to the left 3 places. Okay? But there's something else. There is a plus 1. This plus 1 caused the graph to shift up 1 unit. That is why the resulting graph looks just like this. It's the original absolute value function shifted 3 units to the left and 1 unit up. And then you just get your absolute value function. So that's basically how to use the transformation methods to graph absolute value functions. Alright, so how well did you master the contents of this presentation that we just went over? To demonstrate mastery, we'd like you to try out the following problems. So try these. We'd like you to graph the given absolute value functions. Using transformations. Okay. Alright, so for question 1, let's say you have the absolute value function y equals the absolute value of x plus minus 3. Number 2, what if you have y equals the absolute value of x minus 3 minus 1? And then number 3, let's say you have y equals the absolute value of x plus 2 plus 2. Alright, so go ahead and pause this video. We'd like you to try graphing these 3 absolute value functions. When you're done, go ahead and click play in order to... Alright, hopefully you had a chance to try out the problems. Now let's talk about the answers real quick. Now if you take a look at the first one, in the first one there are no shifts in the x direction because there are no numbers grouped with the x inside the absolute value function. So the only shifts that we're going to have are the shifts up or down, or the vertical shifts. So you're going to shift 3 units. Since you have a minus 3, it's going to be 3 units down. And that will take us to the vertex. Since there's no shift in the x direction, you have 0. And then 3 units, negative 3 for the y because you went down 1, 2, 3, 3 units. For the second one, we have shifts in both directions. Since we have minus 3 grouped with the x, okay, that means we're going to go in the x direction in the opposite way, which is 3 units to the right. So 3 units to the right. And then since we have minus 1, that's 1 unit down in the y direction. So that will take us to the vertex. 3 to the right and negative 1. As you can see here, 3, -1 is our vertex. Now, for this one over here, we have shifts in both directions also. This is positive 2 is grouped with the x, so we're going to do the opposite move, which is 2 units, not to the right, ladies and gentlemen, but to the left. 2 units to the left. And then we have +2 for the k. That is 2 units upwards. Remember, you have x minus h plus k. That minus h means you always do the opposite. That takes us to the vertex. -2, since we're going 2 units to the left, comma 2, since we're going 2 units up. And then you just draw your v function. And there you have your absolute value functions. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of the graph of transformation, functions of transformation, including absolute value functions, do give us a thumbs up. If you have any questions or comments or requests, you can paste it in the comment section below. Don't forget to subscribe to our channel for updates to other presentations such as this. More resources to help you master algebra can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.